Hi there! Have you ever wondered what a magnetic field really is? We see magnets attracting paperclips, feel the force in electric motors, but what is this invisible force? Today, I'm going to share a surprising truth. In the usual sense, a magnetic field doesn't actually exist. It's not a separate force of nature, but a manifestation of the same phenomenon, depending on how we move. In school, we learned electricity and magnetism are two different forces. Charges create an electric field, and moving charges create a magnetic field. But 20th century physics changed this view. Electric and magnetic fields are actually two aspects of the same entity, the electromagnetic field. And the most amazing part is that what you see, electricity or magnetism, depends entirely on your frame of reference, on how you move relative to the charges. Let's take a simple example. A current-carrying wire. At rest, it is electrically neutral. Positive ions and negative electrons are balanced. But if you start moving along the wire at the same speed as the electrons, the situation changes. Einstein's special relativity tells us that lengths of moving objects appear different. Electrons are slightly spread out. Ions are slightly compressed. The balance is disturbed, and the wire appears electrically charged to you. What is a magnetic force in the lab becomes an ordinary electric force for a moving observer. One interaction, two descriptions. And what about a permanent magnet on your fridge? There's no visible current there. But magnetism here is also linked to motion, on the quantum level. Electrons in atoms have spin and move around the nucleus. In a magnetized material, millions of electron spins align in the same direction. Their collective motion creates the macroscopic magnetic field. There is no separate magnetic substance. It's all a complex dance of electric charges. This also explains why we don't see magnetic monopoles in nature. Why aren't there isolated north or south poles? Because a magnetic field is a side effect of moving charges, and its field lines are always closed loops. They can't start or end at a single point like an electric field. A free monopole would prove that magnetism is a standalone force, but we haven't found any. So, a magnetic field isn't a separate force. It's a language we use to describe how the unified electromagnetic field manifests in our moving world. Every time you use a magnet, a compass, or an electric motor, you're witnessing a direct consequence of relativity. Magnetism is a window into the structure of space and time, showing how electricity, motion, and space-time are intimately connected. If this idea amazes you, it means you're starting to see the world in a deeper way. Magnetism isn't magic, it's a reflection of how our universe really works. And if you want to continue exploring these scientific wonders, don't forget to like this video and subscribe to the channel. Here, we uncover the most fascinating mysteries of the universe and explain what's behind the everyday things you thought you understood. See you next time.